Chapter 4, Differential Equation. So in order to solve differential equation with separable variables, so first we have to identify our x dx. We need to separate the separable variables first. So we have 3 steps. So in order to solve this question or this chapter, we have 3 steps. So please remember these 3 steps. The first step is separate the variable. Separate the variable. Okay, which is x dx and y dy. Okay, second, we need to integrate both sides, right and left. And the last one, we solve the question. Okay, let me look at the first example here. Okay, so example is solve the separable first order differential equation with dy over dx is equal to 3x over y minus 5. Okay, so our first step is we need to separate both in term of dy and dx. So we just cross multiply our function. So we move upwards. So y minus 5 multiply with dy is equal to 3x dx. Okay, this is our first step. Separate for the variable of x and y carefully. Okay, our second step is we need to integrate both. So when we integrate y, we will get y squared over 2. When we integrate 5, we will get 5y. We integrate 3x, we get 3x over 2. 3x squared over 2. Okay, this one plus c1 and this one plus c2. Okay, later we rearrange the function, which is y squared over 2 minus 5y is equal to 3x squared over 2 plus capital C. So just let your answer left until this. Example 2. Okay, we have equation of dy over dx equal to x squared e power of y when our y1 is equal to 0. So what we need to do, we need to separate the variable first. Okay, we rearrange the equation. So the first step, we will get integration of dy over e power of y is equal to integration of x squared dx. Then we integrate both sides. Okay, let we put our e power of y to the numerator. It's become e power of negative y dy. So equal to x squared dx. Then we integrate this function. We will get negative e power of negative y plus c1 is equal to x power of 3 over 3 plus c2. Okay, then we combine the equation both together. We will get e power of negative y equal to x power of 3 over 3 plus c. Okay, since we are given y1 is equal to 0, so we just substitute our x. Okay, y1 is equal to 0. So this is our x, which is equal to 1. So we just substitute our x equal to 1 into this function. So our fx or our y equal to 0. So negative e power of 0 equal to 1 power of 3 over 3 plus c. Okay, then we will get c is equal to negative 4 over 3. So after we get the value of c, we substitute back into the function that we have found previously. Then we substitute here, we will get e power of negative y equal to x power of 3 over 3 minus 4 over 3. or we can put e power of negative y as our denominator. So our final answer, we will get negative 1 over e power of y is equal to x power of 3 over 3 minus 4 over 3. So this is the solution for our second step. Okay, next, we looked at example C. We have our dy over dx is equal to 25 minus 4y squared over 3x plus 1. So we rearrange first the function by cross multiply. So integration of dy over 25 minus 4y squared is equal to integration of dx over 3x plus 1. Okay, so how to solve this equation? So if we look at our dy integration, so it's look like inverse trigo. So this is our a, okay, this is our a square, and this is our u square. So our a square is equal to 25. So our a is equal to square root of 25, which is equal to 5. Then our u square is equal to 4y square. So our u is equal to square root of 4y square, which is equal to 2y. Then, okay, this one for dy over dx side. Okay, y for the other side is we need to solve by using u substitution. So for u substitution, u is equal to 3x plus 1, du over dx is equal to 3, then dx is equal to du over 3. Okay, so for the left hand side, okay, let we solve together. Okay, so for 1, integration of 1 over a square minus u square du is equal to integration of 1 over u du over 3. We will get 1 over 2, 1 over a. This is from the formula of table inverse trigonometry, right? Then tangent inverse u over a plus c. So equal to 1 over 3 ln modulus u plus c. C2, this one is C1. Okay, then we just plug in our a and u. So 1 over 2 times with 1 over 5. Tangent inverse, our u is 2y over our a is 5. Plus with C1 equal to 1 over 3 ln modulus 3x plus 1 plus with C2. Okay, then we open the bracket, we will get 1 over 10 tangent inverse 2y over 5 is equal to 1 over 3 ln 3x plus 1 plus c. Okay. Next, let we look at homogeneous differential equation. So what is homogeneous differential equation? So we have 6 steps to solve this function. So the first one, we need to let the equation in the standard form of dy over dx is equal to f multiplied with y over x. Then second step, we substitute y equal to vx, and then dy over dx is equal to v plus x dv over dx. Then separate the variable of v dv is equal to x dx. Then the fourth step, we need to integrate the both sides. Later then we solve and substitute the value of v equal to y over x. So let me solve example 3. So for example 3, the first one, okay, so the first one, we are given y equal to vx. Okay, remember this is the formula for homogeneous differential equation, which is y equal to vx and dy equal to v plus x dv over dx. Okay, so the first step, we need to separate first our x dy is equal to, we move the equation of negative to the right hand side, then we will get x plus x power of 4 plus y, okay, all of this multiplied by dx. Okay, then we need to, for the second step, okay, we need to write down in terms of dy over dx. Okay, so from here we will get our dy over dx is equal to x plus x power of 4 plus y over x. Okay, then we simplify by divide each numerator by its denominator, then we will get 1 over x power of 3 plus y over x. Okay, this one we get from the division of numerator and denominator. Okay, next. Okay, so from here, remember the value of y is equal to vx. So we substitute. Okay, we substitute y into of vx, and remember also our dy is equal to v plus x dv over dx. Okay, so the next step, we need to replace our dy equal to v plus x dv over dx equal to 1 plus x cubed, and our y is equal to vx over x. Okay, so from here we simplify. V plus x dv over dx is equal to 1 plus x cubed plus v. Okay, then what we need to do next, we need to simplify this. Okay, simplify this, so we will get x dv over dx is equal to 1 plus x cubed. So our v can be cancelled because when we minus, our v becomes 0. Okay, next step. Step number 4, we need to differentiate the function in terms of dv and dx. So we have dv is equal to integration of 1 plus x cubed over x dx. Okay, so we separate both for numerator and denominator by divide each other. Okay, or we just write down x cubed over x, we will get x squared here dx. Okay, so this is our v. Okay, or v plus c1. Okay, so v plus c1 is equal to ln modulus x plus f power of 3 over 3 plus c2. Okay, then we can combine c. So our v becomes ln x plus x cubed over 3 plus c. Okay, then don't forget to replace back the value of v. So what is the value of v? Okay, we have y equal to v over x. So our v is equal to y over x. So don't forget to replace back our v here with y over x. Then we will get y over x is equal to ln modulus x plus x cubed over 3 plus c. So remember, at the end of the answer, you need to leave your answer in terms of y and x. Okay, so your y is equal to multiply all here by x in order to let your y as a subject. So this is your final answer. Okay, example 3. Solve the homogeneous first order of differential equation. So let we follow our previous example. The first step, we need to separate this function in term of dy over dx. We will get equal to x square plus 3y square over 2xy. Okay, and then we separate one by one. We will get 1 over 2 times with x over y plus with 3 over 2 times with y over x. This one I simplify from top. Okay, so after we get this, we need to substitute our y equal to vx and our dy over dx is equal to v plus x dy over dx. Okay, this is the basic formula for homogeneous. Okay, so we just replace our dy over dx with v plus x dy over dx is equal to 1 over 2v, because v is equal to y over x. Okay, so x over y is equal to 1 over v. Okay, plus with 3 over 2v. Or we can bring our v here to the right hand side. And then we will get like this. Okay, so we simplify at our right hand side. We will get 1 over 2v plus v over 2. So we solve, we will get x dy dv over dx. Sorry, this is our dv over dx now, because we already changed to dv, and our function also changed in terms of v. 1 plus v square over 2v. Okay, so from here we cross multiply again. Okay, we rearrange the order. Okay, we rearrange in terms of v and x. Okay, so we will get 2v over 1 plus v square dv is equal to integration of 1 over x dx. So let t is equal to 1 plus v square. Okay, so we have dt over dv is equal to 2v, and dv is equal to dt over 2v. Okay, so in order to solve the right hand side, we need to substitute by using substitution. Okay, multiply with dt over dv. Sorry. This is dt over dv. Sorry, the dt over 2v is equal to integration of 1 over x dx. Okay, then we simplify 2v we can cancel. We have only 1 over t dt is equal to integration of 1 over x dx. So we solve, we will get ln t is equal to ln x plus c. Okay, then remember what is t? So t is equal to 1 plus v square is equal to ln modulus x plus v. But remember, at the end, you need to replace your v with y, which is v is equal to y over x. Okay, so you will get 1 plus v square over x is equal to c. Or other s, if you want to cancel the ln, you can put in term of exponential. So e power of ln 1 plus y square over x is equal to e power of c. Or you can cancel A and ln, and then you will get one plus y square over x square is equal to x e power of c. Okay, so this is our final answer. Okay, next we move to the linear differential equation. Okay, linear differential equation. So first, you need to know, in order to solve the linear differential equation, you have several steps. So the equation must be in order of dy over dx plus px times y is equal to qx. The first step, you need to write the equation in term of dy over dx plus pxy is equal to qx. Okay, then find the factor of IP, which is Ix is equal to e power of x dx. Then we need to multiply both sides with IP. And number 4, write the equation in the product rule, which is e power of px times y is equal to e power of px dx qx. Then we integrate both sides by the respecting of x. Okay, let me look at example 4 here. So for the first equation, we have dy over dx plus 2 over xy equal to 3x plus y. So the first step, we need to rewrite the equation in terms of dy over, okay, we need to rewrite, let me check first whether this equation in terms of dy over dx plus px times y is equal to qx. Okay, if we look at here, so we have dy over dx for the first step. Okay, it's same. The first step is dy over dx. Okay, number 2, second step, we have px times with y. Okay, so this is our px times with y, which is our px is 2 over x. And this one is your qx, which is qx is equal to 3x plus 1. Okay, so from here, we need to proceed for the second step. Okay, for the second step, e power of px. Okay, this is the formula. E power of px dx is equal to e power of, so our px is 2 over x dx. So we solve, we will get, solve for the integration symbol first, we will get 2 ln modulus x plus c. Or other as, we just put 2 as a power, it's become e power of ln modulus x power of 2 multiplied with e power of c. So e power of c, that we substitute with a here. Okay, so let this one is our a. Okay, so we can cancel e and ln. What left? X power of 2 multiplied with e power of c, we have replaced with a. So x power of 2 times a. Or we can rearrange, we will get a x power of 2. Okay, it's not finished yet. Okay, next what we need to do is, okay, a x power of 2, ax power of 2 times with dy over dx plus with 2 over xy is equal to ax power of 2 times with 3x plus 1. Okay, so this is the equation. Okay, why we get this is from our equation here. We multiply both sides, right and left, by ax power of 2. Okay, so from here we proceed to step number 4. This is step number 3. Okay, so for the step number 4, we need to differentiate differentiate x square y is equal to x square multiply with 3x plus 1. Okay, so from here we solve for the next step, which is for step 5 step. Okay, integration of x square y d over dx okay, this one also dx is equal to integration of x square times with 3x plus 1 dx. Okay, when we integrate, we will get x square y is equal to 3x cubed over 3 plus with x square. Sorry, this is 3x cubed je, not over 3. Okay, this is, we need to integrate later on. dx. Okay, so x square y is equal to 3 over 4 x power of 4 plus x cubed over 3 plus with c. Or if you want to put x power of 2 below, so all multiply with below because we have x power of 2 here. So we only want y as our subject. So our y is equal to every single number here need to divide x power of 2. So x power of 4 divided by x power of 2, we will get x power of 2 here, plus with x power of 3 plus multiply divide by x power of 2, we will get x over 3 plus with c over x power of 2. Okay, let me look at example 4 here. So for the example 4, B. Okay, so we have a question of 2x dy dx. Okay, so first of all, we need to rearrange the order in terms of dy over dx. So dy over dx plus 1 over 2xy is equal to 3x plus 1. Sorry, this is only 3x. Three, 3x. 3x over 2. Okay, so this is our px equal to 1 over 2x. Please bring together the division symbol. And our qx is equal to this one, 3x plus 1 over 2. So don't forget to rewrite our px and qx. Okay, this is our first step. So second step, what we need to do is integration the symbol. So e power of 1 over 2x dx is equal to e power of 1 over 2 integration of 1 over x dx. Okay, so e power of 1 over 2 ln x plus with c. Okay, so we want to cancel e and exponential. We can bring the power to the top, 1 over 2 here, times with e power of c, or other as e power of c, we substitute with a. Okay, this one is, we assume is equal to a. So we will get e power of, then we solve, we will get ax power of 1 over 2. Okay, so from here, don't forget to substitute back. Okay, ax power of 1 over 2 multiply with the original function that we have simplify previously, which is dy over dx, plus with y over 2x is equal to ax power of 1 over 2 times with 3x plus 1 over 2. Okay, then we simplify this one. We will get, okay, a we can cancel because both right and left hand side we already have a with the same value. So x power of 1 over 2 multiply with dy over dx plus x power of 1 over 2 1 over 2xy is equal to 3x power of 3 over 2 over 2 plus with x power of 1 over 2 over 2. Okay, so we need to differentiate x power of 1 over 2y. Then we simplify the number. We get 3x power of 3 over 2 plus x power of 1 over 2 divided by 2. Okay, this is makes us more easy to differentiate. So then we integrate both sides, dx and dy, but we cannot separate, simplify macam tu. So dx can cancel from the dx at the above. So we need to integrate d of dx, integrate x power of 1 over 2 square is equal to 1 over 2 integrate of 3x square over 2, 3x power of 3 over 2 plus x power of 1 over 2 dx. Okay, then we integrate. We will get x power of 1 over 2y equal to 1 over 2 times with 6x power of 5 over 2 over 5 times with 2x power of 3 over 2 over 3 plus with c. Okay, then we simplify this one. We will get 3x power of 5 over 2 over 5 is plus with x power of 3 over 2. Okay, x power of 3 over 2 over 3 plus dengan c. Okay, then from here we need to substitute the original function. Y equal to 3 over 5x square plus 1 over 3x plus c over square root of x. Okay, then let me look at number D. Okay, so number D, integrating factor. So first is all we need to simplify our dy over dx must be in term of 2y over x. Sorry, this is 2y 2y. Okay, so 2y over x is equal to 10x power of 2, 10x power of 3 over x because we have x in front. Okay, then second next step is, this is the first step. Second step, we need to integrate our x equal to integration of px dx. Okay, so when we integrate, we will get our x is equal to integration of px dx. Okay, we just substitute our p, which is p is integration of 2 over x, 2 over y, sorry, 2 over x. Over x dx. Okay, so we will get e power of ln x square plus dengan e power of c is equal to a e power of 2. Okay, so then we integrate. Okay, from here, sorry, not ae but ax. e power of c is a, so this one is x square actually. Okay, then from here we need to integrate a x power of 2 dy over dx plus 2y over x is equal to 10x square multiplied by ax square. So d over dx multiplied with x square y is equal to 10 x power of 4. Okay, y x power of 4 is come from x power of square previously. Okay, so from here we integrate d x square y is equal to integrate of 10 x power of 4 dx. Okay, so from here we integrate, we will get x square y is equal to 10 x power of 5 over 5 plus c is equal to y equal to 2x cubed plus c over x square. So this is all the example of chapter homogeneous, separable, differential equation. Thank you.